The exterior angle inequality gives us a lot of other inequalities for triangles. The first of which, in our triangle ABC, if AB is greater than alpha over 2 and BC is greater than alpha over 2, then the distance between A and B plus the distance between B and C is greater than the distance between A and C. So if I add up two of the sides, it should be bigger than the third. The first result I have, in triangle ABC, if the distance between AB is less than or equal to alpha over 2 and the distance between BC is less than or equal to alpha over 2, then the distance between A and B plus the distance between B and C is greater than the distance between A and C. So essentially, if I add up two sides of the triangle, it should be greater than the third side. First, if the distance between A and B and C are both equal to alpha over 2, then the distance between A and B plus the distance between B and C is equal to alpha, which is definitely greater than the distance between A and C, since that's the maximum possible distance. We're now going to assume the opposite. We're going to assume AB plus BC is less than or equal to AC. And then we're going to hope to arrive at a contradiction. We're then going to construct two things. The first is we're going to construct a segment AD congruent to AB on segment AC, so something right here, D, where AD and AB are congruent. We're also going to construct a point E so that segment CE is congruent to segment BC, once again on this segment DC. So I'm going to go ahead and draw these two here. We then have the triangle ABD and triangle BEC are isosceles triangles, and they have congruent base angles. So the isosceles triangle theorem and the exterior angle inequality is going to give me, we know that the measure of angle ABC is greater than or equal to the measure of angle ABD plus the measure of angle EBC, since essentially I took this angle and cut out a piece. Using isosceles triangles, I get this is the same as the measure of angle ADB plus the measure of angle BEC. This is greater than or equal to the measure of angle ADB plus the measure of angle BDC, since angle BEC is the exterior angle of this tiny triangle in the middle that has angle BDC. And we know those are equal to 180. So then angle ABC is greater than 180, which is a contradiction. We can't have an angle bigger than 180, which means what we assumed in the first place, this AB plus BC is greater than or less than or equal to AC, must be false. While I will not prove it directly, this then gives me the triangle inequality. The fact that the distance between A and B plus the distance between B and C is greater than or equal to the distance between A and C. And this equality case comes only when I'm talking about a straight line. And I have ABC. Then I would have the distance between A and B plus the distance between B and C is equal to the distance between A and C. Other than that, it refers to the actual triangle that we were just discussing. We would need the distance between A to B plus the distance between B and C. It has to be greater than this distance between A and C. So this can also be explained by the idea that the shortest distance between 2 points is a straight line. The next thing I want to show, if I know that angle A is greater than angle B, then I know that the side length A is greater than the side length B. So essentially, larger angles means larger sides. So let's assume that angle A is bigger than B. Then I want to construct this point D on our side, BC, such that this angle DAB is congruent to the angle B. The isosceles triangle theorem gives us then that the distance between A and D is equal to the distance between B and D. I then know that the distance from B to C is equal to the distance from B to D plus the distance from D to C, which is the same thing as the distance from A to D plus the distance from D to C, which the triangle inequality tells me is greater than the distance from A to C. So the distance from B to C was our little a, the distance from A to C was our little b, so I know that side length A is bigger than side length B if angle A is bigger. Very much related to this, I have the idea that if little a is greater than little b, then big A is greater than big B, essentially meaning that if I have a longer side, it's going to correspond with a bigger angle. Let's suppose A is greater than B. Then one of three things must be true. Either angle A is bigger than angle B, they're equal, or angle A is smaller than angle B. If angle A is equal to angle B, then side length A is going to be equal to side length B by the fact that isosceles triangles have to share angles and sides. If angle A is smaller than angle B, then by my previous theorem, side A would be smaller than side B, which is a contradiction. So we're left with the only other possible case, angle A is the biggest. And both of these can be combined to give us what's known as the Scalene Inequality, which says in any triangle ABC, if BC is greater than AC, if and only if the measure of angle A is greater than the measure of angle B. Like I said, this just combines those last two ideas of bigger sides mean bigger angles, and bigger angles means bigger sides.